Hi everyone. In this lecture, I will cover the first part of chapter 15, which is about linked lists in Java. So the goal of this chapter is to first learn how to use the linked list provided in the standard library, and then to be able to use iterators to traverse linked lists. So let's first see what a linked list is and how efficient it is. A linked list consists of a number of nodes, each of which has a reference to the next node. So adding and removing elements in the middle of a linked list is efficient because you can simply change the reference of the previous node and the next node of the place that you want to put the new element in. Or when you are removing an element, all you need to do is change the reference of the previous element and make it point to the element in the next node. So adding and removing elements in the middle of a linked list is efficient. We'll talk about it later too. And then visiting the elements of a linked list in sequential order is efficient. So if you want to start from beginning and traverse every node and go further and further using the next pointer, it is possible and it is efficient uh, node traversal. However, random access is not efficient. For example, it's not like arrays that you can say, I'm going to access to the fifth node immediately. If you want to access to the fifth node, you have to start from the first node and skip the first four to reach to the fifth one. So the random access operation is not efficient in linked lists. So let's look at a figure that schematically shows how to insert an element into a linked list. Let's assume that you have a linked list of strings containing four strings: Diana, Harry, Romeo, and Tom. As you see, every node in the linked list has two different features. So it have two different instance fields. Uh, the first one is a string that contains a constant string like Diana, and the second is a pointer to the next node. And then at the beginning of the linked list, we have a pointer that points to the head of the linked list, which contains Diana in this case. So let's assume that you want to insert another string with name Juliet in it after Harry and before Romeo. How can we do it? The pointer that Harry's node refers to Romeo should be updated, and it should refer to the node Juliet. Instead, node Juliet should refer to the node Romeo as its next node. So this is how we add a node to a linked list containing a chain of nodes. So let's take a closer look at linked list class in Java. First of all, linked list class is a generic class. What does it mean? It means that you can specify the type of elements in an angle bracket or in two angle brackets. How? For example, if you want to have a linked list of a class like product, you can write linked list, open angle bracket, product, close angle bracket. The whole thing, the whole linked list and the class name enclosed in angle brackets is the name of the class that you have, name of the linked list that you have. So you usually have, we always have a linked list of a class. The class that linked list is implemented on is represented inside two angle brackets. So linked list class is inside java.util, so you need to import this package. And then let's look at the methods in this class, in the class of linked list. Let's assume that we are talking about a linked list of strings, for example. So as I said, linked list is a generic class, so you need to specify a class inside brackets. So when we say linked list of a string, it means that we have a linked list in which each node can store one string. If it was linked list of product, each node would store one object of product. So linked list of a string LST is defined in the following way. We first can instantiate an object from it by calling its constructor. So we say LST is equal to new linked list string open and close parentheses, which calls the the default constructor of linked list string, which returns an empty linked list of strings. Then you can apply a method like add last. Add last adds the explicit input parameter to the end of the linked list. So when you add last Harry, it adds an element to the end of the list, and that element has in a string in it called Harry. And there's another method like add first. Add first will add the object or will add a node at the beginning of the linked list. So if you add Sally using add first after adding Harry using add last, the linked list looks like this. Sally comes first and then we have Harry because we use add first to add Sally. And then we have another method which returns the first element of the linked list. It's called get first. So basically get first returns the element is stored at the beginning of the list. It has no input parameters despite add first and add last. Get last gets the element stored at the end of the list. In this case it's Harry. So Harry is returned by the method get last. Sally is returned by the method get first. And then you can remove a node from your linked list from the beginning of your linked list by calling remove first. So if I call remove first in this linked list, it removes the first element of the list which contains the string Sally, and then the list becomes a list of only one string which contains Harry. So if you call remove last, you have the similar effect. Instead of removing the first element, you have to remove the last element. So if you call the remove last on this linked list containing Sally and Harry, then Harry will be removed. And then remember that both remove first and remove last, they return the removed node. They remove the string. In this case, either it returns Sally if you remove first, or it returns Harry if you remove last. And finally, the last method that I'm going to talk about in this slide is called list iterator. List iterator provides an iterator for visiting or traversing all the elements or all the nodes in the list. So when we call this method, it returns a list iterator of strings. We'll talk about this list iterator class, which is a generic class, later, but all you need to know for now is linked list has a method called list iterator. So let's see what a list iterator is and how it works and what's the motivation of using a list iterator. First of all, list iterator is a generic class that you can specify a type in which the list iterator operates on using the open and closed angle brackets, similar to what we had for linked list. And you need to know that list iterator gives access to the elements inside the linked list while protecting uh, the linked list from being modified. So it's a safe access method to the elements of a linked list, and it encapsulates a position anywhere inside the linked list. So whenever we are dealing with the list iterator, we need to know that that list iterator uh, points to a position inside the linked list. We don't know where, but we can trace the position of a list iterator if we look at the program from beginning to the end. I'm going to show you different examples in this lecture. Here is an example, a schematic view of a linked list of strings and a list iterator of strings. So this was what we have seen before, which is a list of 4 strings: Diana, Harry, Romeo, and Tom. And also we have a list iterator that is working on this list and points to one of the positions or one of the nodes in this linked list. As you see, list iterator string has a pointer that points to Romeo. The last thing that I need to mention here in this picture is that the pointer of the last node in the linked list doesn't refer to any string, and it is null, which means it is full zeros. So a list iterator has an initial position and has a method called next that you can call it, and you can make that iterator or list iterator point to the next position. And you can call the insert method for a list iterator, which inserts an element to the position that the list iterator points to. So let's assume that we define a list iterator. Initially, its position is at the beginning of the linked list. Let's assume that the linked list is the same as we saw before. It contains Diana, Harry, Romeo, and Tom. So after calling next, this iterator, which I specify it with the a vertical red line, moves to the next position, which is a position between D and H. You can think of iterator like a cursor in a text editor. Then when you insert J, which is Juliet, it's like typing J in a text editor where the cursor was here. So when you type a J, J is inserted here, and then now the cursor is again behind H and after J. It was behind H and after D. Now it is after J and before H. That's the conceptual view of the list iterator and how insert and next methods of a list iterator works. So as I said, you need to think of an iterator as pointing between 2 elements. And a good analogy is to think it like a cursor in a word processor or word editor, which points between 2 characters. Also, you need, as I said before, the list iterator that points to a position inside the linked list can be obtained by calling the list iterator on that linked list. So let's assume that you have a linked list called employee names, which is a linked list of strings. you can define a list iterator of strings called iterator, and you can set it equal to the list iterator method of employee names. So now iterator points to the beginning of that employee names linked list. So as I said, initially the iterator points before the first element. The next method moves the iterator one position forward. So iterator.next points to the next element in that linked list. You need to remember that if you're already past the end of the list and you call next, then the method next throws a no such element exception. So in order to avoid that exception, you can first check whether there is a next element by calling hasNext method of the iterator. The hasNext method returns true if there is a next element. If there is not, it returns false. So before calling next, you can say if iterator that has next dot has next, then you can call iterator.next to avoid throwing a no such element exception. So let's see how list iterator can be used to traverse all the nodes of a linked list. This is the first solution. You need to know that the next method returns the element that the iterator is passing. For example, if the iterator is passing Diana, it returns Diana. So for example, if the iterator is before Diana and after calling next, it passes Diana, so it returns the string Diana. So in order to traverse all the strings or all the nodes in a linked list, and all the strings stored in the nodes of a linked list, you can write the following code. While iterator.hasNext, which means while we haven't reached to the end of the linked list, do the following. First, you say a string name is equal to iterator.next. This would return the next element in the linked list, and then you can do whatever you want to do with a string name. This is one way of traversing a linked list. But there's a short form for this while loop. You can use a for loop like this. This for loop basically does the same exact operation that we have seen before, but it is easier to write and it's easier to remember. You can simply write for a string name, column employee names, do something with name, which is in a string. So basically, behind the scene, the compiler converts this for loop to this while loop that you have seen. So behind the scene, the for loop uses an iterator to traverse all the elements in the linked list. The reason that we can use this notation is because linked list is a list. So every list in Java can be traversed in the following way. In a for loop, all you need to write is you write the element that is stored in one of the nodes of that list. In this case, it's a string called like name, and then a semicolon, colon, and then the name of the list that you have. This way, the for loop will traverse all the elements available in that list. It's important to know that the linked list in Java is a doubly linked list. What does it mean when we say we have a doubly linked list? It means that every element has a reference to the next element, and also it has a reference to the previous element. So the class stores two links, one to the next element, one to the previous element. In order to move the list position backwards, you need to use hasPrevious method to check whether there is a previous element or not, or you are already at the beginning of the list, or and then also you can use a method like called previous, which is similar to the method next, instead of moving forward, previous moves backward. So if you use a list iterator and call its previous method, it uh, moves the position of the iterator backward, and then it returns the element that the iterator just passed. So let's look at how to add and remove an element from a linked list. If you have a linked list and you have an iterator pointing to the one of the positions inside that linked list, the add method of iterator does the following. First, it adds an object after the iterator, and then it moves the iterator position past the new element. So if you say iterator.add Juliet, it first adds an object after the iterator with a string Juliet stored in it, and then it moves the iterator position past the new element which contains Juliet. So let's see how to remove an element in a linked list using the remove method of the list iterator. In order to remove a in order to use the remove method, you need to call next or previous before calling the remove method. So look at this code. You have a while loop which says while iterator that has next is true, which means while there is a next element, do the following. First, write a string name is equal to iterator.next. So in the first step, you call the next method, and then you simply say if that string, for example, fulfills some condition, then call the remove method of the iterator. You can simply write iterator.remove. When you do this, it will remove the object that was returned by the last call to the next or previous method. So the remove method removes the object and returns the same object that was returned by the last call to next or previous method. So as I said, you need to be careful when calling remove. It can be called only after calling next or previous. For example, here we have two next method calls and two remove method calls. The first remove method call is okay because it is called after the next method call, but the second remove method call is not legal because it doesn't come after calling next or previous. So you cannot call remove twice, one after each other, one after another. So you have to put a next between these two remove method calls so that it becomes a legal operation. Also, you cannot call remove method immediately after a call to add method. What does it mean? You cannot first call add Fred, for example, and then remove. If you want to call remove, you have to first call next and then remove, or call previous and then remove. If you call remove improperly, either after an add or if you call remove twice back to back, then the one that is called improperly throws an illegal state exception. So you can take a look at this table which summarizes all the methods that we have covered so far. At the end of this lecture, you need to take a look at a sample program uh, that does the following. First, it inserts strings into a list, and then it iterates through the list and it adds and removes elements while iterating through the list, and then finally it prints the whole list. So make sure to read this sample problem carefully. Uh,